The following presentation is on three-dimensional systems of equations. So what makes this a three-dimensional system of equations is there are three unknowns, x, y, and z, and three different equations. What I'm going to do first is I'm going to label each equation with a number, 1, 2, and 3, so it makes it easier to talk about them later on. And the goal for three-dimensional systems is to eliminate one variable at a time. So I take a look at the problem I have, and I decide which of these variables would be easiest to eliminate. And I'm going to choose z to eliminate first. So the first step is to eliminate the variable z from equations 1 and 2. So to eliminate z from equation 1, I need to multiply it by positive 2. 2x plus 6y minus 2z equals negative 8. And then I don't need to change equation 2, so I just rewrite it the exact same as it is. Okay, so now I've eliminated my z variable, and I'm left with 4x plus 5y equals negative 5. Sorry, positive 5. And then I'm going to eliminate z from a different combination. So this time I'm going to eliminate with 2 and 3. So equation 2 I keep the same, 2x minus y plus 2z equals 13. And then I'm going to multiply equation 3 by positive 2. 6x minus 4y minus 2z equals negative 18. And when I combine these two, my z's drop out, and I have 8x minus 5y equals negative 5. And what I've done is I've eliminated the first parameter and created two new equations. So I'm going to call these two equations number 4 and number 5. Now I have a regular system of equations just like last week. So what I'm going to do is I'm going to combine these guys, and I'm going to eliminate y from 4 and 5. The reason why I chose to eliminate y is because I already have the opposite coefficients. 8x minus 5y equals negative 5. So my y's cancel out. I'm left with 12x equals 0, and when I divide by 12, I get x equals 0. Here's the first piece to my answer. We are not done here. We need to solve for x, y, and z. So what I'm going to do with this x is I'm going to plug it into either equation 4 or 5. In this situation, I'm going to plug it into 4. And what that's going to help me do is solve for y. So I have y equals 1. So now I have x, I have y, and I need z. So what I'm going to do is I'm going to plug in x equals 0, y equals 1 into equation number 1. So I have 0 plus 3 times y minus z equals negative 4. Negative z equals negative 7. Z equals positive 7. So my coordinate point that I have is a three-dimensional coordinate point. 0, 1, 7. I do need to check my answers. I need to check my answers in these two equations that I did not use already. So I need to make sure that it works in equation 2. So that's 2 times 0 minus 1 plus 2 times 7 equals 13. This one checks out because I have negative 1 plus 14 equals 13. That's checked, and then we check it again in equation number 3. The reason why we have to check it in all three is because it needs to work in all three. 3 times 0 minus 2 times 1 minus 7. And hopefully that equals negative 9. So negative 2 minus 7 equals negative 9. And do me a favor, whenever you do 3D systems of equations, can you box your answer, please? Your coordinate point? So then I don't have to go hunting all over the page for it.